In this video, we will explain a question related to maximum area through the use of quadratics. The example question that we are using in this video, as can be seen, is about finding the largest swimming area possible on a beach. The beach's manager wants to design an area for swimming, and he has only 360 meters of rope to get the maximum area. Our job here is to find the dimensions of the largest swimming area possible, which will allow us to find the maximum area. So, to begin with, let's have x represent the width of the swimming area and let y represent the length, which is the side parallel to the beach. This gives us an equation of 2x plus y equals 360. Rearranging this equation for the value of y, we get that y equals 360 minus 2x. Now, we all know that the equation for area is a equals length times width. In this case, it would be a equals x times y. Using the value we found for y, we get a equals x times 360 minus 2x. In order to find the maximum dimensions, we must now identify the vertex. By extension, we must also find the x-intercepts. So, in order to find the x-intercepts, we need to make sure that either of the terms in the equation equal to 0. So, from this equation, we can see that x is equal to 0, and by setting 360 minus 2x equal to 0 and isolating for the value of x, we get that x equals to 180. Therefore, the x-intercepts are x equals 0 and x equals 180. The vertex's x value is the same as the axis of symmetry. To find the axis of symmetry, we must identify the midpoint of the two x-intercepts. To do this, we apply our midpoint formula, which we all know is x1 plus x2 divided by 2. Using our two x-intercepts 0 and 180, we add them together, divide them by 2, and we end up with 90. Therefore, the axis of symmetry is x equals 90. Now that we've found out that vertex's x value, all we have to do is sub in that value into the original equation to find the y value. Now, our original equation was y equals 360 minus 2x. Since the vertex x value was 90, we replace that x with the 90 that we found as our, as our axis of symmetry. This makes the equation look like this. 90 times 2 gives us 180, and so subtracting 360 minus 180 gives us 180, which gives us the value of y. Therefore, the vertex's x-coordinates are 90 and 180, which is our maximum value, as can be seen in the graph. So, now we have our maximum dimensions. 90 is the maximum length, and 180 is the maximum width for the swimming area. Since we have the maximum dimensions, we can also get our maximum area simply by multiplying the length and the width. The product of 90 times 180 is 16,200 meters squared. Therefore, the maximum area is 16,200 meters squared, and the maximum dimensions are 90 meters by 180 meters. Well, that's all we have for you in this video. We hope you've perfectly understood the method for maximizing area.